Now, the last aspect of the organic we shall be looking at today. I have not covered all, but at least I've been able to cover the, let me say, 60% of organic. So the last aspect we shall be looking is when carbon bound with oxygen. Here we should be looking at the light of having alkanol, and the functional group is OH. We can be having alkanoic, and the functional group is COOH. We can be having the light of aldehydes, and the functional group is CHO. And then we can be having the light of ketones, and the functional group is what? CO. Then when carbon bond also with nitrogen, so we can have amides and amides. So let's look at this. I told you initially that when carbon bond with oxygen to form carbon dioxide or carbon monoxide, that one is not taken as what? Organic. But when carbon bond with oxygen and it forms the line of alkanol, alkanoic, aldehyde, ketone, ester, that is the one we regard to as what? Organic. So, how do we get this alkanol? It is coming from the word alkane. You can see alkane, which means we are adjusting alkane to sweet alkanol, to sweet alkanoic. How? What we need to do is that just take away one hydrogen of alkane, take away one hydrogen atom of alkane, and replace with this functional group. Please watch out for this. The functional group for alkanol is OH. The functional group for alkanoic is COOH. The functional group for aldehyde is CHO. The functional group for ketones is what? CO. So how do you form alkanol? It's very simple. It is coming from alkane. What you have to do is that remove one hydrogen atom from any member of alkane and replace with what? OH. Very simple as that. For instance, methane. Methane is CH4. Methane is CH4. So this is methane. If you remove one hydrogen atom now and you replace with OA, we'll be having CH3, then OH. What I have on the board is what? Methanol. So very simple to form this group. And all of them is pronounced like O. So this is methanol. The second of alkane is ethane. Let's look at ethane. Ethane is C2H6. If I'm not mistaken, that's 2 times 2 plus 2. So it's correct. So if you remove this, remove just one hydrogen atom, and we're having C2H5OH. This is what? Ethanol. This is formula for ethanol. So it's very simple to form this group. So note it. How do we form alkanol group? We form alkanol group by removing one hydrogen atom of alkane and replace with what? OH. So we shall be forming the family of alkanol. Methanol. This is methanol, and this is what? Ethanol. Now, how do we form this? Alkanoic. At times we call it carboxylic. At times acid. At times we call it alkanoic. Here, we can form this by removing one atom of carbon. Remove one carbon of atom and remove three atom of hydrogen. In the alkane group, because this one too is coming from alkane, aka. So whatever family of alkane you want to work on, remove one carbon. Remove one carbon and remove 3 what? Hydrogen. When you are done removing one carbon and 3 atom of hydrogen, replace with what? COOH. For instance, let's do that here now. I want to remove one atom of carbon. Of course, when I remove carbon, this one is gone. Then they said 3 of hydrogen must also go. So I'll be having 1 hydrogen left. Then with what? COOH. What you have on the board is methanoic. It's just as simple as that. Methanoic. Now let's go for ethanoic now. Ethanoic acid. Now, the Lord said we should remove one C So let us remove one C and be having one C. The Lord said we should remove 3 hydrogen. So let us remove 3 hydrogen and be having 3 left. And the Lord said we should replace with what? COOH. What we have on the board is what? Ethanoic acid. Just as simple as that. So that is how we can form hacanoic and alkanoic. Hacanoic is formed by replacing one hydrogen atom of alkane by OH. Alkanoic is formed by removing one atom of carbon and 3 atoms of hydrogen and replace with the functional group called COOH, and that is going to form noic. Now, aldehyde, how do we do this? We can form this one by removing one atom of carbon and then remove the same 3 atoms of hydrogen. It will not look like this. Why? Because we are replacing with CHO, meaning the same law go for both of them. But what gives differences between them is what we are replacing after removing. We are removing one atom of carbon, 3 atoms of hydrogen. We are removing here to 1 atom of carbon, 3 atoms of hydrogen. But when we replace with COOH, it is for alkanoic. When we replace with CHO at the end, it is called aldehyde, and that is the one that ends with methanol, ethanol. So let's look at the example. So this is one example. So methane, for instance, methane. The Lord said we should remove 1 atom of carbon. I have done that, and then remove 3 atoms of hydrogen. Then replace. I have removed 1 atom of carbon, gone. Remove 3 atoms of hydrogen, gone. I have 1 hydrogen left. Then replace with what? CHO. What we have on the board is called methanol. Methanol. Look at it. Methanol. So the functional group of Na is CHO. CHO is Na. So it depends on. So if you want to get ethane as well, remove 1 atom of carbon, I've done that. Remove 3 atoms of hydrogen, I've done that. Then instead of COOH, replace with CHO. So what you have on the board is called ethanol. Ethanol is what we have on the board. So you can from here form the other member. Now that is not ketones. This is a functional group of ketone. This time around, we are removing just 1 atom of hydrogen. We are removing just 1 atom of hydrogen in what? In ketone. We are removing, 1 atom of carbon and 2 atoms of hydrogen. And then we are putting CO at the middle. Remove just 1 atom of carbon and remove 2 atoms of hydrogen and replace at the middle with what? CO. For instance, let's pick anyone now. Let's go to the bottom. Remove 1 atom of carbon. So this one is propane, C3H8 propane. Now remove 1 atom of carbon. So I'll be having 2. So this is C. This is another C. So C2 remain. Then remove 2 atoms of hydrogen. I'll be having 6. This is H3. This is H3. Then in between them. So this is pronounced as propanol. So we continue from the next class.